Okay, we're going to go ahead and start our first subunit of the upper level chemistry content. Up until now, we've just done reviews for middle school content, but if it wasn't a review to you, you are now up to date or up to the level we need you at to be understanding the next units. So after this unit, I want us to be able to explain organization of electrons within an atom, describe what energy level, sublevel, atomic orbital is, draw the shapes of each sublevel, and predict how many electrons can be held in each energy level. So we've all heard about the quantum mechanical model. It's the model that has replaced the Bohr-Rutherford model, the one with the rings around it. But we can't pinpoint where the electron is, but we have a probability of where the electron is. And that, remember, that was done by a mathematical equation, thanks to Schrodinger. Electron configurations show how electrons are distributed within an atom. So it's basically an electron's address within an atom. That's all electron configuration is. That's all it is. Okay, so if you'll remember, I've already told you guys this Bohr-Rutherford model isn't the most up-to-date model, but we do still use it. Even college professors will kind of reference it in class, and we will go back and forth between quantum model and the Bohr-Rutherford model. So don't forget it, but it doesn't look like this, okay? It's not some kind of planetary orbital type system. Okay, so one of our words I wanted us to kind of get exposed to is energy levels. So keep in mind, guys, those rings around the nucleus, those are just energy levels, okay? And they're always represented by a whole number, okay? We will learn how to assign numbers when we do quantum number subunit, but just know that they're represented by a number, and there's never a half number, it's always a whole number. So you'll never see an electron in the middle of these rings, okay? So basically, it's just the distance away from nucleus, like I said, and as you go away from the nucleus, the energy will increase. So the energy is the lowest here and highest here. Okay, so within each energy level, electrons will occupy sublevels. So do you remember in class when we were talking about the periodic table, how this was the P block, this was the D block, this is the S block, and this is the F block, and I made you draw each of those shapes. Remember the S shape was a sphere, okay, but I drew it as a circle. But I showed you this thing and I said, guys, remember, I'm drawing a circle, but it's actually 3D and it's a sphere. And then we went on to say that here's the P block right here. And then I made you draw the P block shape, and I drew this, and you guys are laughing at me because it looked like an 8, but really I wanted you to know that it looks like this, okay? It's a 3D model. And then the d orbital added more of these dumbbell things, and then the f orbital added even more. And then it just looked horrible. My double clover, it got worse and worse as I drew more. So that's what we're talking about when we're talking about sublevels. Sublevels are just those shapes that they're in and the orientation that they're in. So they correspond to a different area that an electron can be located in an atom. We represent those letters by the S, P, D, and F. So you guys have heard about those. G, H, I, you won't do that in this class. You actually don't do that in IB. You might do it if you go to get a degree in chemistry, but they're just theoretical, and I just want you to know that, you know, it does go on, but not in 10th grade for sure. Okay, so the shapes we've drawn already in class. If you were absent that day, we went over these and I showed you models in class. I can't find my models. I'm sure they've put them up, and that was very sweet of them, but now I need them and I can't find them. But these are the models that we kind of drew on the board. It looked really bad, like flowers and stuff, but keep in mind they were these 3D model shapes. I found like remnants of my model kit, but whatever, it's good enough for now. So keep in mind that they are not flat. That's my main thing I want you to know. They are 3D, and the electrons that's just a probability of where you can find an electron in that atom, okay? Okay, so types of sublevels in this energy level. You can memorize this, but this is going to kind of be like common knowledge to you by the end of this unit. If you're doing the practice problems and watching the videos, you'll know that energy level 1, which if we're we're just going to do a generic atom here. So this is just the nucleus. And energy level 1, okay, energy level 2, energy level 3, energy level 4, okay? So energy level 1 would have 2 electrons, okay? And so energy level 1, it has an S shape, okay, or an S orbital, okay? Energy level 2, energy level 2, that will have another S sublevel and a P. Actually, it can have up to 3 P's, but we'll learn that in the next slide, okay? Energy level 3. So remember the energy levels, we're just talking about the ring. It has another S, another 3 P's, okay? And now we are starting into the D block, okay? And then we go on to energy level 4, and then we have another S. I'm sorry, that was supposed to be a comma. Another 3 P's, 5D orbitals, and now we are into F territory, okay? And then there's energy level 5 and 6 and 7, but it doesn't get any higher than F in 10th grade, and even that, F is a little weird. I'm going to show you how I expect you to do it, but if you go on to higher level chemistry, not even IB, but higher level, there's like some of the electrons get kicked down into the D orbital, and it gets a little weird, but my way is a little more consistent, and it serves the purpose of what I want to teach you. Okay, so atomic orbitals. So each sublevel is oriented differently in 3D space. So what that means is the P, you know how it's drawn like this on your paper, right? And it looks like it would just stay drawn like this, but actually there's like one here, and then there would be like 2 more dumbbells kind of connected here. Let me go see if I can. Okay, I'm sorry. So let's say, so like another orientation, sorry, these are very old, and my new kit that I ordered at the beginning of this year is not here. So this would be like 1 p orbital and one certain, like, it looks like it would maybe for you guys be the X plane, and then this would be Y plane, and then it can do one more, in the Z plane, but we'll talk about that later, but just know that they can be oriented differently. That's all I want you to know in this slide. And that each one holds 2 electrons. So the S orbital holds 2 electrons. This p orbital can only hold 2 electrons. This p orbital holds 2, and then the third would hold 2, and that's why it needs 3 p orbitals, because there are actually 6 electrons in the p orbitals total, so there are 3 p orbitals, each one holding 2. Okay, so this is kind of what I was telling you was coming. The S sublevel, there's only one of them. Okay, so for each energy level, so for each ring, you only have one S. Okay, so you only have one S. You have a sphere on this one, a sphere shape here, and a sphere shape here. And then the P sublevel, you have 3 of them. And the D sublevel, you have 5 of them, and F sublevel, you have 7 of them. G is theoretical. I'm putting it up here just to be evil and confuse you. But just know that you won't be asked about the G orbital. This is the only time you're going to be hearing it, unless you go on further and they speak of G orbital and you're like, oh yeah, okay, I know that. Or G sublevel, you say, yeah, okay, I knew this was coming. Give it to me. Okay, so orbitals for a particular sublevel are similar in shape but different in orientation and size. While you're looking at that, basically in this sublevel, let's just look at the S orbitals, okay, so I don't confuse you with my crowded drawing. So in this energy level, okay, you have a sphere, okay, so that's the S orbital for the first energy level, okay, that's a 1. First energy level, okay. Now, the second energy level, okay, it also starts off with the sphere. okay, but it's going to be bigger than the first one, okay, and covering it. And remember, it's a sphere, so it's circular, it's spherical, it's not a flat circle. So you actually no longer see this one. Then, so this would be the S for the second energy level. And basically in that last slide, all I wanted you to know is that they are bigger and they kind of cover it. It does change size as you go up the energy level. So energy level 3, it will have an even bigger S shape. And remember, energy level 2 had S and P. So energy level 2, not to confuse you, I told you I wasn't going to, but it also had those 3P. Wow, that was a bad dumbbell. I told you I shouldn't have drawn that. P orbitals. But anyways, it's going to be even bigger than the second energy level's S and P orbitals, okay? So, and then it just gets bigger and bigger and bigger. So that's what it means by it changes in size as it goes up the energy levels. It's just getting bigger and bigger, and each S orbital will cover the P's and D orbitals. So this one, you guys all year have been asking me how many electrons are located in each ring. And if you look at this, you'll see that the third sublevel, I told you it would get a little weird because this first row of D, or the first period of the D group, is actually part of the third sublevel. So yeah, your third sublevel does have these 8 electrons in it. But then you go to the fourth one, which has 2, and then you have the third sublevel will have another 10. So that's why I told you it does get weird. We'll talk about that in class as well, unless you guys just get it. So energy level, it basically increases as you go up in energy level. So energy level, the S orbital is the lowest energy level, and then F would be highest. If we're going to theoretical, G would be higher. So electrons prefer to occupy the orbitals that require the least amount of energy. So even if we are in this second sublevel, and let's say we're talking about lithium, okay? Can you see lithium, which has 3 electrons? So we're in this second sublevel, and there's only 1 electron. It's going to occupy an S sublevel before it'll start a P. So basically it's S and then S and P and then SPD, okay? So know that it always occupies that S sublevel first. That's it. Please, guys, post your confusion to the forum, okay? And answer it. Otherwise, we will move straight ahead and take the test early. So as you get questions, put it in the forum. I can have a more focused lesson with you guys in class instead of taking up time and explaining some of this. We can go over the most difficult part for you. So please post a question in the forum. It's already there as to what you don't understand or what you would like me to elaborate on, or we can show some more examples. So that's basically it. I just wanted to introduce you to the energy levels, which are the rings, the shapes, the sublevels, which are the shapes of them. There's an orientation, so it's not just one p orbital. They kind of stack on top of each other, and then that they change in size. So there's not just one size of S orbital. And yes, this is a Christmas ornament. There are multiple sizes. They get bigger as you go out into the energy levels. Okay.